In this long question, we will look at properties of sound, graphical representation of sound, and also the wave equation. So first up, explain sound basically. So tuning fork will first vibrate, and as it vibrates, I've shown you all the slow-mo video of the tuning fork. It pushes the air molecules around it, and it will cause the air molecules to vibrate to and fro about the equilibrium position. And you must also mention that this vibration is then passed on. The idea of passing on, that's the whole concept of wave. This must be mentioned. So this disturbance of air molecules is then passed on from one molecule to another molecule by collision. That's the keyword, collision must come out. And that's how the energy or the sound is transmitted from the source, which is the tuning fork, to the other places, which is the microphone in this case. Now, in part B, you're given that between the tuning fork and the mic, there are 4 complete waves as shown here. So 4 complete waves is basically just 4 times wavelength. And the distance between these two is 6.8 meters. So immediately I can figure out what's the wavelength. So if I know the wavelength to be 6.8 meters divided by 4, I can use the wave equation to figure out what is the wave speed, because the frequency is given to me as 200 Hertz over here. Now in B part 2, if I change the frequency to 2000 Hertz instead of 200 Hertz, you are asked to figure out what is the number of waves. So take note that the speed of sound doesn't change. So once you calculated the speed of sound to be 340 meters per second, it remains constant. The frequency now increases to 2000. You can basically recalculate what is the resulting wavelength of the sound wave that travels. So the wavelength now is 0.17 meters, and therefore within 6.8 meters distance between the tuning fork and the microphone, how many 0.17 meters can you fit in? So just do a simple division, you get 40 cycles. Lastly, you are told that the tuning another tuning fork is used to produce a sound wave that is half the pitch and half the loudness as the first sound wave. So basically half the pitch means you half the frequency, which means that over here you can see originally there are 3 complete cycles, 1, 2, and 3 complete cycles. Now you half the frequency, means instead of 3 cycles and 3 waves inside, you only half it, you only have 1.5 cycle, 1.5 wave. So this is how I would draw the 1.5 waves. So basically you have 1 full wave here and then another half. So 1.5 waves. You can also look at it in terms of wavelength. If the frequency is half, means the wavelength is doubled. So previously the wavelength is from here to here. This is the wavelength. But now the same distance here for the blue graph is just half the wavelength, because the full wavelength is now doubled onto here already. Okay, so two ways to figure this out. Loudness is half means the amplitude is half. So amplitude was here, now it's half lah. Alright, so this is how we can sketch the new graph.